This is Geometry, Semester 1 Exam Review. We're working on Unit 4. We're going to find the value of x looking here at this triangle. We're going to use the Triangle Sum Theorem, which means that the three angles of the triangle must add up to 180 degrees. So I know that 24 plus the 5x plus the x has to add up to 180. So collecting our like terms makes 6x. We can divide by 6, and x will equal 26. So classify the triangle by its angles. Well, this is 24, which is an acute angle. This is 26, apparently, because it's just x. Now, what is 5 times 26? 5 times 6 is 30. 10 and 3 is 130. So this is 130 degrees. So it's called an obtuse triangle because one of its angles is greater than 180 degrees. I'm sorry, greater than 90 degrees. This next one, again, we know that the three angles must add up to 180 degrees. It's called the Triangle Sum Theorem. So that gives us 4 x's. And when we divide by 4, we get 45. So each one of those angles has to be 45. The x, and then the 2x is going to be twice that amount. That's going to be 90. So we have 90 degrees. So that makes this a right triangle because it has a 90-degree angle. It can only have a maximum of 1 right angle, and it can only have a total of 90 or bigger. Only one angle could be 90 or bigger. This is the exterior angle theorem. Okay, the exterior angle theorem says the exterior angle of a triangle is equal to the sum of the non-adjacent interior angles. So that's telling us that this exterior angle here is going to equal the sum of the non-adjacent. Remember, adjacent means right next to it. Non-adjacent, that means the two farther away. This angle equals the sum of those two. So we're going to get 2x that equals 57 plus 58. So 2x is going to equal 115. And when we divide that by 2, we'll get x equals 2 goes into 11 5 times with 1 left over, goes into 17 7 times with 1 left over, so we get 0.5 because it's 1/2 left over. Answering the question says find the value of the variable. And that's what we did. X is 57.5. Here, you've got to work on the skills that it takes to problem solve how you can go about this. Several problems, there's multiple ways. We can look at this one, and I am looking for the value of x. X is an exterior angle. We can just set the record straight. There are no alternate interior angles here because of parallel lines, so we don't know anything's equal to each other. We don't have any advantages like that. Vertical angles aren't necessarily helping us. None of those special rules. But a linear pair, two angles that add up to 180, that makes this one 180 minus 126. That makes this 54 degrees. Now we can use the exterior angle theorem. The exterior angle equals the sum of the non-adjacent angles. So I know that x is going to equal 93 plus 54. I got 147. On this next one, looking for different ways that we can problem solve to figure out our variables. I see a triangle here, and with that triangle I have three angles. I know the Triangle Sum Theorem tells me that they add up to 180 degrees. So I'm going to say that 61 plus 31 plus x is going to add up to 180 because those are the three angles inside of a triangle. That gives me 92 plus x equals 180. Subtract my 92 across, and my x is going to be 88. So x is 88 degrees. Y makes 180 degrees with the x. So now I can say 180 minus the 88, of course, is 92. That was another exterior angle theorem I could have used. This would be your exterior angle of that one, and its sum is equal to, or its value is equal to the sum of the non-adjacent angles. Now looking for z. Well, z would be another triangle sum theorem. So we could say that 180 is supposed to equal 25 plus 92 plus z. That gives me 117 minus the 117 we get 63. And remember, z, which is apparently 63, these two here, which adds up to 88, is supposed to equal this exterior angle, another exterior angle theorem with that inside triangle. So there's the x, there's the y, and there's the z. Write out all possible congruent statements for the two triangles. Well, we can take this first triangle and we can name it ABD. And if you name it ABD, then that's going to be congruent. it's going to be congruent to only one specific triangle. There's 6 ways to name your first triangle, but there's only one that's going to match it. So I started with A, which was the 90 degrees. I now go with C. The B was here at the end of the parallel line. So for this triangle, it should be down here at D. And then I go along the transversal to get up to B. I could have changed those letters and started with A and switched the D and the B. That would have kept me with C and switching the B and the D. I could have started with BAD. The B is supposed to go with the D. The A always goes with the C. And the D is always going to go with the B. BDA is another way you could name the triangle. I've done 2 triangles that start with A, 2 triangles that start with B, and then now I actually have 2 triangles that start with D. D always goes with the B, the A always goes with the C, and the B is always going to go with the D. Then my last option, triangle DBA, is congruent to triangle BDC. So there are 6 ways to name the first triangle, but there's only one correct match for every one of those. So write out all possible congruent statements. That's what we did for these 2 congruent triangles. Looks like we could practice that one again. So here I'll DED, or AED, sorry. A down to E was down the 2 tick line. So I need to pick the side that has the 2 tick sides. That's CEB. So now I'm going to switch the letters of the E and the D, and that will switch the letters of the B and the E. I'll let the E come first. So the E goes with the E because those are the vertical spots. The A goes with the C, and the D goes with the B. I'm going to start with the first letter of D this time. D always goes, because that's down the 1 tick line, with the B. The E always goes with the E, and that means the A will always go with the C. Switch the second 2 letters. So those are your 6 ways that you can name those 2 triangles with a congruent statement. List all pairs of corresponding sides and angles. Well, here's the picture. We know that angle R is going to go with angle X. We know down the 1 tick line the V must go with the Z. And the 2 tick line takes me to the T, and the 2 tick line takes me to the Y. I could also tell that by looking at my congruent statement. The first letter has to go with the first letter. angle T is congruent to angle Y. Angle R, which is the second letter, goes with angle X. Angle V is congruent to angle Z. So sometimes the picture is pretty easy to read, but you can't beat a congruent statement. That tells you everything you need to know. So now the side lengths, we can look here and look at where the 2-tick side is, which happens to be this one, and the 1-tick side and the no-tick side. Those are going to line up correspondingly. But an easy way to do it also is that the first two letters, T and R, must be congruent to the first two letters, YX. T and R is going to line up with Y and X. The second two letters, which maybe you'd say were RV, are going to line up with XZ. So R to V, from X to Z, down the 1-tick line, R to V down the 1-tick line. The first and last letter, TV, notice how it starts up near the 2-tick line and it comes down to the 1-ticker. YZ does the same thing. It starts near the 2-tick line and it goes down to the 1-ticker. You want the order to match also. So following your congruent statement is very helpful. You don't have to get confused by looking at the picture. So I listed all the pairs of congruent angles and all the pairs of congruent sides. So we're going to determine which method can be used to prove the triangle is congruent. So looking here, both triangles have a 1-tick mark, both triangles have a 2-tick mark, and both triangles share the side that's in between. It's called the reflexive property. So now I have two A's and the S that is not in between those two A's. It's called angle side congruence. There are 5 possible ways to name triangles congruent. Those 5 ways to name triangles congruent are going to be side, 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 angle, side, angle, side, angle, 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 side, and RHL. Notice that AAA is not one of the options, and neither is something that starts with SSA or has 2 S's with a non-included A. So the congruent statement for this one, you can pick any of the 3 letters in any order you want. So let's go A, B, C. That makes one of the triangles. And a correct congruent statement. The A has the 2-tick mark on it. So the C has a 2-tick mark on it. The B has the 1, and that corresponds with the D. So that leaves us with the A. So here, looking, we both have a 1-tick mark. We both have a 2-tick mark. And there's the side that's in between. It looks like we have some arrows here. So we could talk about alternate interior angles. Looks like we have some right angles. So you could talk about how this is a right triangle. So I think RHL could possibly work. It looks like side angle side could work, but I'll just go with the most easiest one I noticed. 1-tick mark, 2-tick marks, and then the one that they share in common is called the reflexive side. So we're going to use side, side, side. Congruence. And the way we're going to name that triangle, I'll name my first one with any three-letter combination, ABD. The A has the right angle, so that goes with the C. The B is out at the point or at the end of the parallel line, so that's going to be D. And then the D is down at a bigger angle down here off the one ticker. So off the one ticker leads you up to the B. Here when we look at it, looks like we have a right angle. And notice how there's a big X that's happening here, or a big plus sign. That makes vertical angles. So we know that this is going to be the same measure. So the box shows that it's a right angle, which makes it 90 degrees, which makes it a right triangle. So we have a right triangle. We have the two tick marks, which are across from that, which is your hypotenuse. And we also have the side that's running perpendicular for the right angle. We call those a leg. So we have RHL congruence. R stands for right triangle, H stands for the hypotenuses are the same, and L stands for a leg, which clearly is not the hypotenuse. So we'll name the first triangle FIH, and it's congruent. What goes with the F, that's at the end of the two tick mark, so that's J. The I is here at the 90. We end with G. So for this proof, we have a regular pentagon. The key term here is regular. Remember, whenever you do a proof, you want to look at the given information. You want to look at the picture and see how that correlates. Then you want to look to see how you would use your own words to reach this conclusion of how to prove it. Well, a regular pentagon tells us that all of our sides are the same length. A regular pentagon also has all the angles the same length. So that's what a regular pentagon is going to be. Now, we want to come to the conclusion that ABC, triangle ABC, is congruent to triangle EAD. So this triangle, I'll kind of highlight it here, is supposed to be congruent to that one. And we have to use one of our 5 ways that we've talked about. Well, we do have 2 S's that match 2 other S's, and the angles in between those S's are also the same. So it looks like we're going to prove them congruent by side angle side. So our given tells us it's a regular pentagon. Now, if we have a regular pentagon, or I'm just going to call it a polygon, if we have a regular polygon, then all the angles and all sides are congruent. And that's what they're saying here. They're saying at least these 2 angles are the same because all angles are the same, and these sides would match because all sides match. So we just proved it by side angle side. This next proof, looking at our given information, we see that BC, that's this line up here, is congruent to DA. So if your picture is not already labeled with your tick marks, you want to be sure to do that. Angle 2 and angle 1 are congruent, so we'll put the curve markers in there. Now, here they want us to prove triangles congruent. I need to specifically see which triangles I'm referring to. BEC happens to be this one. Okay, so that's telling us we don't have to look at the big triangle. We're just looking for that top triangle. And then DEA happens to be this other one. That's the other triangle we're looking at. So far I have a pair of sides and I have a pair of angles that match. I need to come up with something else. Well, there isn't any side that they're sharing, but there is a big X that's being formed by those two triangles. That's going to give me vertical angles here in the middle. And I put 2 tick marks on it to show that they're congruent to each other, but perhaps different than the angle 1 and 2. So now it looks like I have 2 A's and the S that is not in between those A's. Notice how I came up with a plan. I didn't do the proof till I had a plan. So we have our given. It talks about vertical angles like we discussed. You need to use 3 letters to name vertical angles. So angle DEA. Those 2 angles are vertical. Notice how the middle letter is your vertex, and it's the one here in the center. You got to use 3 letters. Then the triangles are congruent by angle, angle, side. Some people like to call that side angle, angle. Not that that's a big deal, but it's always written as angle, angle, side. So that's the best way to write it. Number 14. Looking up at our picture, notice how the picture doesn't have anything labeled. So we want to take our given information, and it says that angle BAC, B to A to C, this angle here, and this angle here are congruent to each other. We also know that angle DCA, and BCA, they're congruent to each other. Now, that's 2 bits of information. They're both A's. Now I have to find a 3rd bit of information. I'm going to prove the triangle's congruent, because if the triangles aren't congruent, then I can decide if they're corresponding parts, or then I'll know that their corresponding parts are congruent. So I'm assuming that BC, which is this segment, and DC, if the triangles are congruent, then I know those are congruent. So the extra piece that I'm missing is a side. It's a side that they share. Notice how both segments have the same AC or CA segment. So that's called the reflexive property. So we'll start out with angle BAC is congruent to angle DAC. Angle DCA is congruent to angle BCA. The middle letter tells you where the vertex is located. So these 2 angles are talking about the double tick marks, and these 2 angles over here that have the A in the middle are talking about the single tick marks that I drew. We have the reflexive property of congruence. then look at the hint that they're giving us. ASA, angle side angle. They're telling you that this refers to proving triangles congruent. So what triangles would be congruent if you knew these angles and that side? You can name it in any order you wish. Let's start with A, then B, C, and then we'll go the corresponding A, because they both have one tick mark, D, and then C corresponds with C because they both have two tick marks. Now, this last step to prove sides are the same, let's find it up in our picture. DC were these two segments. In our congruent statement, DC are your second two letters, or those are BC, and DC here are your second two letters. So they're in corresponding parts. That helps reinforce that. If two triangles are congruent, then corresponding parts are congruent. That's the best way to write it. If two triangles are congruent, we've shown that earlier. Remember, all ifs have to be shown earlier. If the triangles are congruent, then corresponding parts, which these are, have to be congruent to each other. The shortcut that your book talks about for this statement is to call it CPCTC. Corresponding parts of congruent triangles are congruent. So it says the same thing this statement does, just not in the same order. We prefer the if-then statement, but I'll accept CPCTC. Here's our last one for this Unit 5. T is the midpoint of PR. So PR goes all the way across. T is the midpoint. So if it's the midpoint, I know these two segments are the same. And it's also the midpoint of QS. So that makes these two segments the same. I don't know that they're congruent to each other, but I do know that T breaks it in half. We have to prove that PQ is congruent to RS. So we've got this long segment congruent to that long segment. You got to come up with a plan on how you can do this. What's going to allow parts to be congruent? Well, we could talk about triangles. If we knew triangles were congruent, then the corresponding parts would be congruent. That's what we just finished doing. If I looked at this top triangle again, which has a 1 tick mark and a 2 tick mark, I could look at this bottom triangle that also has a 1 tick mark and a 2 tick mark. You've got to come up with a reason and a plan on how you're going to do that. That seems reasonable. So we're going to start out with our given information. PT and RT. So if midpoint, then corresponding, if a midpoint, sorry, it's not corresponding, sorry. What happens with a midpoint? If a midpoint, then we have two congruent segments. If a point is the midpoint of a segment, then it divides the segment into two congruent parts. That would be the best statement to use. But I'll let you shorten it up some and say if we have a midpoint, then we have two congruent segments. Okay, where is this PTQ and this RTS? Why would those two angles be congruent? Notice we wouldn't say anything about alternate interior angles or corresponding angles or anything like that. We haven't talked anything about being parallel, but we have seen a big X that comes through here. So those look to be vertical angles. If vertical angles, okay, so the vertical angles, they're not a statement that happened earlier, but they are in the picture. That's the if. That's the only one that doesn't come in earlier statements. That's the one that comes in the picture. If vertical angles, then congruent angles, because those angles would have to be the same measurement. So I can put my curve mark in here now. So I'm going to show the triangles are congruent by side, angle, side. And remember, if you have triangles congruent, then they're corresponding parts. Let's see if these two are considered corresponding parts. P and Q are your first and last letter. R and S are also your first and last letter. So that shows that they're corresponding parts. If triangles are congruent, which we had earlier, then corresponding parts are congruent. The shortcut for that, recall, is CP. Corresponding parts of congruent triangles are congruent. That concludes Unit 4 for the Semester 1 exam review.